Hey, what's going on, guys? In this video we are going to talk about integer representation. Integer representation. There are two types of integer representation. One is unsigned, and the other one is signed. Now signed has three parts. The first one is signed and magnitude. Signed and magnitude. And the second one is one's complement. One's complement. And the third one is two's complement. Two's complement. Okay. Now let's look at the properties we have to follow. The first one is only one bit pattern per value. Only one bit pattern per value. And the next thing is equal number of positive and negative values. Equal number of positive and negative values. Negative values. And then the third one is max range of values. Fourth one is no gaps in the range. Okay. Now let's continue here. Now let's look at the unsigned integer. Unsigned integer. Unsigned integer is basically an integer without a sign. It is an integer without a sign. So actually the range is 0 to infinity. Its range is between 0 to infinity. 0 and positive infinity. Positive infinity. Now let's look at the number of bits and the range of each of these number of bits. Number of bits and the range. 8 bits, the range is 0 to 255, and if it's 16 bits, the range is 0 to 65,535. Now let's look at an example. Let's say we want to store 7. Store 7 in an 8-bit memory location. In an 8-bit memory location. Here, in order to do that, what we have to do is first we have to convert 7 into binary. Then we have to add 0 to make 8 numbers. Now to convert this one into binary, you know that binary coded decimal goes like this: 8421. And to convert 7 into binary, we had to have 1 of the 4 and 1 of the 2 and 1 of the 1. That will make 7, and this is going to be 0. Here we have only 4 digits. But if you want to store this in a 8-bit memory location, we have to have 8 digits. So this is going to be, we have to add 40 in front of this. So 0 0 0 0, then 0 1 1 1. This is how we can store 7 in an 8-bit memory location. Now let's look at another example where we store a number to 258 memory location, 16-bit memory location. So let's say example 2. Let's say we want to store 258. Same question, but in this time we are going to store in a 16-bit. Store 258 in a 16-bit memory location. (258). So if you continue like this, here we have 8, 4, like 1, 2, 1 times 2, 2, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64, 64 times 2, 128. And you have to see how much we need to make 258. Now let's see whether we can do with these numbers. 128, 64, 32, 16, 8, 4, 2, 1. Alexa, what is 128 plus 64?
128 plus 64 equals 192.
Alexa, what is 192 plus 32?
192 plus 32 equals 224.
Alexa, what is 224 plus 16?
224 plus 16 equals 240.
240, 248, 252. So this is not enough. So we have to go one step further. Here we have to add 256. Alexa, what is 256 plus 128?
256 plus 128 equals 384.
Actually, I made a mistake. This is 256. It's actually straightforward. I don't even have to think about this. 256 and 1, 2. That will make a 258. Others we had to just put a 0. 0, 0, 0, 0, 0, 0, 0. Okay, so we have 4 zeros. Here it's 0, 0, 1, 0. And here we have 4 zeros, 1. Totally we have how many numbers? 5 numbers here and 4 numbers. So totally we have 9. We need 16 total. So to do that, we have to add 7 more zeros in front of this. So this is going to be 0, 0, 0, 0, 0, 0, 0. Then after that, we have to continue this one. So we will have totally 16 digits. So this is going to be 0, 0, 0, 0, 0, 0, 0, 1, and then 0, 0, 0, 0, 0, 0, 1, 0. And that's how we can store 258 in a 16-bit memory location. Now let's look at some examples of storing decimals in memory locations. Now 7 we can store in a 8-bit allocation, and also we can store in a 16-bit allocation. 234 we can store in 8-bit allocation and 16-bit allocation. But if you look at 258, it says overflow for 8-bit allocation. Why is that? If you look at the notes before, for 8-bit allocation, the maximum allowed range is 255. And here you can see this one is 258. So it's above the limit, above the range. That's why it's overflow. But for 16-bit allocation, the maximum range is 65,535. That's why it's allowed right here. And if you look at this 24,760, that's again overflow for 8-bit allocation. But it allows in the 16-bit allocation, because if you look at the range for 16-bit, that's 65,000. Here we have 24,000, so it's allowed. But for the fourth one, we have 1,245,678, but this is overflow for both of them, because 8-bit, the range is small, so it's definitely overflow. But if you look at 16-bit maximum is 65,535, but here we have 1 million, so that's definitely overflow. That's why we have overflow for 8-bit allocation and 16-bit allocation. And that's all about integer representations. I hope you guys find this video helpful. Thanks for watching. And if you're trying to learn digital logic design 2 or computer architecture, there are a bunch of videos in my playlist. I hope you guys watch it too. Don't forget to subscribe. See you next time.